This video is going to go through the worksheet on projectiles. This is found on the back page of your notes packet. I'm just going to go through each problem for people who are still having a hard time figuring out some of these word problems. So, number one, a ball is tossed from 4 feet above the ground. It is released with an upward velocity of 50 feet per second. When will the ball be 40 feet above the ground? Okay, so first of all, we're going to start with the equation that we have been given in the notes. This is the equation we're always going to use, and we're going to plug in what we know. We're just going to start with a negative 16t squared. That does not change. However, our velocity is 50 feet per second, and our initial height is 4 feet above the ground. The other thing is we haven't done anything with the 40 yet. And the 40 is the height that we're trying to solve for, and so that actually is going to go over on the left-hand side. And the question is asking us when. So we're solving for t. So I'm going to plug in my 40 on the left. I'm going to keep my t's in the equation because that's what we're solving for. I'm just going to take a second and show you kind of what we're looking at here. The ball starts at 4 feet. It goes up to 40 feet. Actually, it doesn't say how high it goes. It's going to go higher than that at some point. So it's going to go up, and as however high it goes, we don't know how high it goes, but it's going to go up a certain amount, and then it's going to hit 40 feet. It's also going to hit 40 feet on the way down. And so our question is, what are those two places where it hits 40 feet? To solve that, we need our equation to be equal to 0. So we're going to subtract our 40 from both sides, and we get negative 16t squared plus 50t minus 36. If we were solving for the vertex, we would do negative b over 2a, but we're not solving for the vertex. We're trying to find what are the values when that is equal to 40. And so when we plugged in the 40, that was our first step along the way. Now we're going to be solving for the x when it was 40. So we need to use the quadratic formula. That's negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to do that with these numbers. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now I'm going to take a second to put this into my calculator. In my calculator, I think the easiest, most direct way to do this is to put it all in as a fraction altogether. So I'm going to go to the alpha and the y equals to bring up my fraction menu. I'm going to hit enter because that gives me a fraction. Okay, now I can plug in my numbers. When I plug it into my calculator, you have to be careful with your minus signs and your negative signs. So it's negative b plus or minus, but we can only do one at a time, so we're doing plus b squared minus, so this is a minus, 4 times a, that's a negative, times c, that should be a negative, and it looks like I made it minus. So I'm going to go back up there and just double check. The reason I think it looks like a minus, can you see how it's a little bit bigger and this one's a little bit smaller? I think that's a nice mistake. So I'm going to make that into a negative. Okay, so now it's a negative all over 2a. And it gave me an error message, and I think I did the same thing on my negative on my 16. So I'm going to fix that to a negative, and now I'm going to hit enter, and it gives me the number 9 over 8. And if I want to change that to a decimal, I can just do 9 divided by 8 equals, and it'll give me a decimal. Or if you wanted to, I can show you how to do that. I'm going to go back and capture that, enter it, and I can go to the math key and change it to a decimal, and it will do that for me as well. But either way, it is 1.125. That is one of the solutions. So I'm going to show you on our paper where that was. That first answer was here at 1.125. Now we need to find the other one. And so on my calculator, I'm going to arrow up and I'm going to capture that whole thing, this one, and I'm going to hit enter, which copies it. And I'm going to arrow to the left and go up. And I'm going to change my plus sign right here. I'm going to change that to a minus sign. And now I'm going to hit enter. And my other answer is 2. So let me show you again. On your graph, that's going to be right here at 2. So our two solutions, when will the ball be 40 feet above the ground? Okay, when will it be 40 feet off the ground? When the time is equal to 1.25 seconds and 2.0 seconds. That's number 1. Let's go on to number 2. All right, number 2, I'm going to start with the same equation. I'm going to look through the problem and figure out where to plug things in. And so my 300 is the question, so it goes over here on the left. My 200 is my starting height, so it's going to go over here on the right. So I have this equation. I need to subtract my 300. I get negative 16t squared plus 96t minus 100. At this point, you can use the quadratic formula. Some people like to simplify it a little bit, so if you wanted, you could divide both sides by 4. That gives us a little bit smaller numbers if we go divide by 4. Some people just like to do that so their quadratic formula isn't so long. I think this first one is just fine. I'm actually going to stick with that first one and do my quadratic formula with that first equation. So I set up my quadratic formula, plug in my my negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go to my calculator and put that in. Okay, so I plug all that into my calculator and I get an answer of 1.34. And once again, there are going to be 2 solutions. We didn't draw it on our paper, but I can show you here in just a second. Okay, once again, we don't know exactly all the information. We don't know how high it actually gets. We could find it, but that's not what this question is asking. It starts at 200, it goes up through 300, and then when it comes back down, it goes through 300 again. And so we're looking for the time when it gets to each of those places. We found one of them to be 1.34. We need to go back to our calculator, change it to a minus sign, and find the other one. So my calculator, I'm going to copy and paste this. And I just hit enter and it comes down. I'm going to arrow over. And I arrow over to my plus sign and I hit minus instead. And I hit enter. And it gives me my second answer of 4.658 or 4.66. And so my 2 solutions are 1.34 seconds and 4.66 seconds. Number 3 is a little bit different. I'm going to show you a graph for number 3, and then we'll work through it. Here is my graph. It is shot out of the mouth of the cannon from ground level, so it's down here at 0, 0 when it starts. It's shot straight upward and returns to hit the ground 6 seconds later. So it comes up, goes down, hits 6 seconds later. The max height is 144 feet, so that's over here. What time does the pumpkin achieve its maximum height? Well, here's its maximum height. What time would that be? The answer there is 3 seconds, and it's exactly halfway through. The only reason it's exactly halfway through is because it starts at the origin. If it was one of those like on the other page where it wasn't starting at the origin, it would not be halfway. But these are halfway. Let me show you on the other page what I'm talking about. Okay, on this graph, here's my vertex. It's not halfway. Because the reason it's not halfway is because it started all the way up here at 200. So that's what I'm talking about. If it starts at the origin, like this one starts at the origin, it's exactly halfway at the vertex. Okay, so the answer to the first question is 3 seconds. That's when it reaches its maximum height. Question B, write an equation to model this situation. It does not say what kind of equation. I'm going to choose a vertex equation because I know the vertex. The coordinates of this vertex are 3, 144. So my vertex form is y equals a times x minus h to the second plus k. I know that my a is negative 16. If you're on Earth, your a is always negative 16. My vertex is 3, 144. That's my h and my k. So it's x minus 3 squared plus 144. That's the answer on letter B. You could have done it in factored form. You could have done it in vertex form. It doesn't say it has to be standard, so this is good enough. Part C asks how high is the pumpkin after 4 seconds. So 4 seconds is our time. So we need to plug in 4 for t. Now, a minute ago, though, I used this equation and I used an x's and y's instead of t's and h's. But do you see that time is on our x-axis? So we're going to plug in 4 in for x. Okay, so when I plug in my 4, I just have to work it out now. And so when I take 144, add it to negative 16, I get 128 feet. So the question was, how high is it after 4 seconds? We could say, maybe here's our 4-second spot, and so it is there at 128. It's a good idea to kind of look at the graph to check for reasonableness, and so that's why I did that. Number 4, some fireworks are fired vertically into the air from the ground at an initial velocity of 80 feet per second. Find the highest point reached by the firework just as it explodes. Okay, we're going to start with our regular equation that we always start with. The first part of the equation doesn't change. Now we do have a velocity of 80, so I'm going to plug that in for my v sub o. The initial height, it says it's from the ground. If it's from the ground, then my initial height is 0. So I just have the equation negative 16t squared plus 80t. The highest point reached by the firework. Once again, I just think it's going to make sense if you draw the diagram. Okay, the highest point reached by the firework is here. That's the vertex. We need to find the vertex. How do we find the vertex with a quadratic? Well, the first thing is we do negative b over 2a. And so when I do negative b over 2a, I get an answer of 2.5. Now we have to think about 2.5 what? Because this is a word problem. It's on the x-axis. Time is on my x-axis. This must be 2.5 seconds. Am I done? The question says find the highest point reached by the firework just as it explodes. I'm not done. 2.5 is the time. That is here. So what I need to find is the height. How do I do that? Well, I'm going to take that 2.5 and I'm going to plug it into my equation. So I'm going to take that 2.5, I'm going to plug it in for this t and this t. I'm going to go to my calculator, I'm going to plug it into my calculator, I'm going to see what I get. And when I plug it in, I get 100 feet. I went ahead, you don't have to do this, but I want to explain what I did with that 2.5. H of 2.5, that means the height after 2.5 seconds. The height after 2.5 seconds is 100 feet. That's where that's coming from. And now we have our final answer. Find the highest point reached, it gets to 100 feet. That's the highest it gets. All right, as always, I'm going to start number 5 by drawing a diagram. A pistol is accidentally discharged vertically upward from a height of 3 feet above the ground. If the bullet has an initial velocity of 200 feet per second, what maximum height will it reach before it starts to fall back to the ground? If you draw a diagram, you can see what's going on. It's starting at a height of 3. It goes up to its max point. That's what we need to find. We need to find what that height is, and then it's going to come back down. So if I plug in the information, I have a 200t and I have a 3 that I know. I need to find my max height. My max height is my vertex. The way I find the vertex is I start with negative b over 2a. Negative b over 2a, I get 6.25. 6.25 what? Well, this is x. X is time, so that's 6.25 seconds. The question was asking for the height. So now I need to take that height, that time, and plug it into the equation to find my height. So I plug that into the equation, I plug it into my calculator, and I get that the height after 6.25 seconds is 628 feet. Okay, number 6. This problem is a little bit different. Let's just go ahead and read through it. The International Space Agency has finally landed a robotic explorer on an extrasolar planet. To demonstrate the crushing weight of gravity on this planet, the camera is aimed at a probe's ground level, that's important, ejection port, which launches a baseball directly upwards at 147 feet per second. The force due to gravity on this planet is 98 feet per second squared. Assuming no winds and that the probe can move out of the way in time, how long will it take the ball to smack down to the surface of this planet? Okay, how long will it take? So we're looking for time this time. We're solving for t. Well, one thing is the gravity is not negative 16. Remember, negative 16 was our gravity. The gravity instead is negative 98. Our initial velocity is 147 feet per second. And our initial height, again, is 0. And so this time we are solving for t. We're not solving for h now because it says how long. We're solving for t. And how long will it take to smack down to the surface of this planet? So it's going to come back down to 0. So we can set this side equal to 0. At this point, if we can factor it, we can factor it. If we can't factor it, we can do the quadratic formula. You really could do either one. But I'm looking at this and I'm thinking I can factor this. I can definitely factor out a t. I might even be able to factor out more than just a t, but if I can't see that right now, this is actually enough. Because now, remember that what we have to do is set this equal to 0 and set this equal to 0. So this one gives me t equals 0. Well, that one is over here. I already knew that. This one is going to give me the other one. And so I'm going to set this factor equal to 0. and I'm going to solve it. I'm going to subtract 147 from both sides, and then I'm going to divide by 98, or negative 98. And so when I take 147 divided by 98, I get 1.5 seconds. That means this point over here is 1.5 seconds. The question, how long will it take the ball to smack down to the surface of the planet? That is 1.5 seconds. Okay, that is worked through all of the problems. If you continue to have questions, please feel free to come in and I can help you with these.